Hi, me is Yak. Me is one of the members for the group F. So, I will present for the part A. First, we will do the numerical form by following Wick's relative density and tensor strength. So, we will find means, standard error, medians, mode, standard deviation, sample variances, range, minimum, maximum, sum, and count. For the count, for these three measurements is 200. Okay, so now we go to the tabular form. Tabular form, we will find first VS frequency. So we will get this chart, and then we find relative density Vs frequency. So we will get this chart, and then we will find the tensor strength Vs frequency. So we will get this chart, and we will find for the tree shift Vs frequency. So from this pie chart, we can see the frequency for the tree shift. So now we will see the numerical form for the shift. First, we will do the row label for the tree shift, morning, evening, night, and then we will find average of week, variances of week, standard deviations of week, average of the relative. So we will go by category. First is week, then is relative density. So we will find average of relative density, and then variances of relative density and standard deviation of relative density. Next, we will go to the category tensor strength. So we will find average of tensor strength, variances of tensor strength, and also standard deviation of tensor strength. Okay, then we will do the range for the week, and then we will do the count for the each range. That's all from me. Thank you.
Hello, my name is Mizigesh Muad. I'm here from group F. I'm gonna present for the question B. As we know here, for our waist it ranges from less than 303 and more than 383, and we count the frequencies for our parameters here. We had here our frequencies, and we have the total here. N is going to be our N, and as we have 9 parameters here, so our V is going to be 9 minus 1, which is going to be 8. And we have alpha equal to 0.001, and Z is going to be, we use the equation of x minus the mean, which is 350, divided by the standard deviation 14. After that, we calculated the probability for our z's, later. After calculating the probability of our z, the total probability, after that we calculate the expected here using the equation E equal to NP. N is here 200, and P that we found here, we found the total E. After that, we are gonna use the x square test, which is gonna be the sum here is gonna be x square test, and as we know, we have the value of x with alpha going to be 0.01, and our freedom is going to be the V here, it's going to be 26. And as we found here, using our goodness of it, as we found here that the x square test is higher than our x here, and it's gonna be the result is reject h0. Our h0, the rejection is gonna be of course h1, so it does not convert for our normal distribution that was stated in our h0.
Okay, Assalamualaikum and good morning to Doctor. So, my name is Muhammad Najmi bin Azlan. We present for part C, which is I need to show the result and the different significant for the weight and shift. Okay, so in this part C, okay, I will use ANOVA. So ANOVA, I want to know there is 3 or more than 3 population means. Okay, so the first step is I will make the pivot table. Okay, pivot table, and then from the pivot table I will classify the result until I get this table on this side. Okay, for 3 shift, morning, evening and night. Okay, and then for this test, okay, I will set a null hypothesis, which is micro 1 minus micro 2, okay, equal to 0, while the alternative hypothesis is equal not to 0. Okay, so I get this x1, x2, s1, s2 and n1, n2 is also from the pivot table. Okay, this value. Okay, and then as we can see in the test, we get this is our alpha. Okay, and then we use the calculation and the calculation, and we get negative 0.4644. Okay, so for the calculation, conclusion for the hypothesis between morning and evening is reject if Z test is more bigger, but in this result we can see that the result is more bigger, so we fail to reject H. Same to the other. Okay, for the test of hypothesis. And then for the ANOVA single factor, okay, we get this f value is from f distribution. Okay, so to get this f, okay, mean square between the group divide by within the group value. Okay, and then from the f we get the p value. This is the p value, and lastly we can see the result. Okay, so the result is S alpha 0.01. We are failed to reject H null, and there is no significant difference in the means. If alpha is 1, we can reject the H null and accept the other significant difference in the means. So that's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rofi from Group F, and I will answer the question. First is summary output. We got the regression statistic. We got 5 point here, and this is the value. Plus we got observation, it's 100. And then for the ANOVA, it's a regression and residual. This is the point DF, SS, MS, F, and then the total for DF is 199, and then the total of SS is 7.53195. Okay, for the intercept is this the coefficient, standard error, P value lower 95%, upper 95%, and lower 95.0%, upper 5.0%. Same like relative density percentage, you can see here. And then next is residual output. Like I said before, the observation is 200. You can check here. 200. This is the predicted tensile strength, and this is the residuals. So Pearson coefficient equals to 0.F4435382. Multiple R is 84.478, which show there is a correlation and acceptable fit. It will predict a correct value at acceptable range significant F. F is this. This is the point F, and then less than alpha. This is the point, which show there is an existence of linearity in the regression model as the beta frame parameter is lower than alpha. It is significantly not zero at 1% significance level, which implies that linearity between the two variables does exist. At any lowest range of alpha, for example alpha 0.00001, there is linearity between the tensile strength and relative density. The residuals show how far away the actual data points are from the predicted data point using the equation, and this is the point y plus point x. And we got this relative density percent line fit plot. For the blue one is tensile strength, and the orange one predicted tensile strength. There is a big strength and direct direction of correlation between the predict and actual value. Okay, I think that's all for me. Thank you.